Right now, as you watch this, a spacecraft launched before most people reading this were born is sending its last dying signals across 24 billion kilometers of empty space, and NASA engineers are racing against time to keep it alive. Voyager 1 is failing, and what it carries with it, if it goes silent forever, is something we may never get back. Here's what's happening, why it matters more than almost any space story in decades, and the one thing about Voyager's situation that nobody talks about, the thing that will genuinely change how you think about how far humanity has actually reached. Stick with me, we're going somewhere very few people have really thought about. Voyager 1 was launched on September 5, 1977. That's not a typo. This spacecraft is 47 years old. It was built with 1970s technology. We're talking about computers with roughly 69 kilobytes of memory. Your phone has billions of times more processing power. And yet, against every reasonable expectation, Voyager 1 has been faithfully transmitting data back to Earth from the very edge of the solar system, from a place we have never and may never reach again. It crossed into interstellar space in 2012, becoming the first human-made object to ever leave the heliosphere, the vast bubble of solar wind that surrounds our sun. Think about that for a second. A machine built by human hands, made of aluminum and gold-plated copper, is floating right now in the space between the stars. But something started going wrong in late 2023, and the crisis has been escalating ever since. In November 2023, Voyager 1 suddenly stopped sending readable science data. It was still transmitting. Engineers could detect the signal, but the data was pure gibberish. Imagine getting a letter from a friend 24 billion kilometers away, but every word is scrambled. And here's the first thing that really twists the mind. A signal traveling at the speed of light takes over 22 hours to reach Voyager 1. That means when you send a command, you wait more than 22 hours for it to arrive, and then another 22 hours for any response to come back. That's almost 2 full days per attempt to fix anything. Engineers at NASA's Jet Propulsion Laboratory spent months troubleshooting across this impossible delay, sending command after command into the dark, waiting and hoping. Eventually, they traced the problem to a single corrupted chip inside the Flight Data System computer, one chip out of thousands, carrying a small but critical piece of the onboard software that translates data before transmission. Their solution was breathtaking in its elegance. They couldn't repair the chip, so they relocated the corrupted code to a different part of the computer's memory. Working in tiny pieces, sending updates across billions of kilometers, they essentially performed remote brain surgery on a 47-year-old spacecraft. And in April 2024, against all odds, it worked. Science data started flowing again.
But that moment of triumph contained a warning that gets much darker the longer you think about it. Because here's the second thing nobody talks about. Voyager's power source is dying, and nothing can stop it. Voyager 1 runs on a radioisotope thermoelectric generator, a nuclear battery that converts heat from the decay of plutonium-238 into electricity. When Voyager launched in 1977, it had enough power to run every instrument simultaneously. But radioactive decay never stops. Every year, Voyager 1 loses about 4 watts of power. That doesn't sound like much, until you realize the spacecraft currently produces less than 250 watts total, less than 4 standard light bulbs. To keep the most critical systems running, NASA engineers have been making impossible choices for years. They've shut down heaters. They've powered down instruments one by one. Each shutdown is a small death, a sensor that has been reporting on the universe going permanently dark. And the trajectory of this is brutal. Sometime within the next few years, and scientists give it no more than 5 to 10 years at most, Voyager 1 will no longer have enough power to operate a single scientific instrument. After that, the transmitter itself will eventually fail, and the signal will go quiet forever. Now here is the moment I promised you, the perspective shift that changes everything. Voyager 1 is traveling at roughly 17 kilometers per second. That sounds incredibly fast, and by human standards, it absolutely is. But here's what that speed actually means on cosmic scales. At that velocity, it would take Voyager 1 approximately 73,000 years to reach the nearest star system to our own, Proxima Centauri. 73,000 years. The spacecraft that represents the absolute furthest reach of human civilization, the most distant object humanity has ever built, traveling at a speed we can barely fathom, would need longer than all of recorded human history times 10 just to cross the gap to our closest stellar neighbor. We sent something to the stars, and the stars are still unimaginably far away. Voyager 1 will never arrive. It will wander in the dark between stars, silent and alone, for longer than our species can probably comprehend. What it does carry, though, is worth remembering. Attached to its body is a golden record, a 12-inch gold-plated copper disc containing sounds and images from Earth, greetings in 55 languages, music from Bach to Chuck Berry, the sounds of rain, surf, and wind, a mother's first words to her newborn child. It was Carl Sagan's idea, a message in a bottle thrown into an incomprehensibly vast ocean. Sagan called it a gift to the cosmos. The odds of it ever being found are almost zero. But the fact that we sent it, the fact that we reached far enough into the universe to send anything at all, says something extraordinary about what we are.
We are the species that, with 1970s computers and 250 watts of nuclear power, punched a hole through the boundary of our own solar system and kept listening for 47 years. The engineers at JPL who stayed up through the night running calculations to save Voyager's signal last year, they knew the spacecraft was dying. They fixed it anyway. Not because it was practical, because it was ours. Because every watt of data it sends back is irreplaceable. Because letting it die in silence without a fight wasn't something they were willing to do. When Voyager 1 finally goes quiet, it won't be the end of exploration. Voyager 2 is still transmitting. The New Horizons probe is still out there. Future missions will go further. But Voyager 1 will be something different from all of them. It will be the first, the one that crossed the line. And somewhere out in the dark, 24 billion kilometers from home, it's still going, still transmitting, still sending us the universe's whisper, one photon at a time, across the impossible distance between where we are and where we dared to reach. If this story moved you, if the sheer audacity of Voyager makes you feel something, hit that subscribe button. We cover the universe's greatest stories here every week. And next time we're going somewhere even stranger, the black hole at the center of our own galaxy that scientists think may not be alone. You don't want to miss it.